Hello everyone, our project is ReviewPal, which is a restaurant review generation system. Nowadays, restaurant reviews are playing an important role in guiding customer decisions. Online platforms allows users to share their experience, but most people only share their quick impression like good food or poor service, which does not provide many useful insights to others. Platforms try to incentivize the detailed reviews by rewards, such as bonus points. But drafting a thoughtful review can be challenging and time-consuming for many users. Therefore, we develop a multi-agent system that leverages the LLMs to help users turn their quick thoughts into the detailed review. To address the challenge of collecting consistent raw user inputs, we started by collecting 100 authentic, high-quality reviews that best represent the output of our system from 20 different restaurants. Using the separate LLM, we reverse engineered these inputs to concise opinions to simulate the quick user raw inputs. Here's an example of the processed data. During processing, we carefully define our prompt based on several criteria. For example, the output should preserve the original sentiment, avoid adding new ideas, and simplify the key features such as dishes or service. The numeric detail were also retained. By doing so, we can reduce the average length of the review from 130 words to 34. Here's the final design of our system. There are 3 GPT-4o agents working together. Agent 2 retrieve and summarize the relevant detail from the restaurants from online resources to enrich the review. Agent 1 takes in the user inputs and then combines it with the restaurant information to draft an initial review. Agent 3 was added to identify and refine any excessive AI-style language in the draft using the chain of thought methods to ensure that our final review sounds natural. We evaluated our system based on 4 key criteria. The output review should be consistent with the user's input. It should effectively use the restaurant information. Also, it should have a human-like tone and be meaningful with overall high quality. Each criterion was rated on a scale of 1 to 5 by a single group member to ensure consistency. To be considered as a successful output, it needed to be scored at least 3 in all criteria. The entire system was considered to be successful if it reached a success rate over 90%.
And here is a complete representative example. The user input is consisting of quick sort from user input, and the agent 2 will extract relevant information from online resource. That's ECE may be benefit for the review generation. And agent 1 will firstly initially generate the review, but which contain massively AI-like language, which we show in the red underlying text. But luckily, agent 3 could catch most of them. And here comes from our final result. We highlight each part of the final result with corresponding user input, and which is, as we can see, most of the user input are colored, which show our system fully capture the original user idea. And also, you can see the final output. It used the retrieval information efficiently to argument the restaurant background, which includes the review quality. And also, you can see the final output. The final output sounds natural and coherent, which give offering the successful insight. And the success rate is 96%. And the table summarizes the average score for each criteria. And since the human-like tone is most struggling part, we summarize the common AI language pattern that we're trying to handle via the prompt design, which include the long clause and the 2 general or 2 formal words choice. And the effective RAG, there's some interesting we want to talk about RAG. RAG is pretty efficient. And for example, there's at one test case, the user mentioned lab in the input, and the system identifies a specific dish and expands the detailed description on this dish and use it to generate review. And also, when there is the inconsistency between user input and retrieval information, our system will act as what we expect, because it always prioritizes the user input. The retrieval information is only used selectively. And finally, our system demonstrated the generation capability of our large language model to actively drive insight based on the user input, and show the brief case at the bottom. And finally, there's some still something other thing that we can improve that we found during the development. Because we found the most challenging part is how to make the generation result sounds more human-like. And to better address this, we could collect sufficient real input from the actually user if time permit. Because in some cases, the AI-like pattern is inherited from the synthetic data. And
Thank you.
thank you.